sailing the blue seas like Magellan of old, the courage of the age of discovery, dreaming of humanity. Beyond Pluto and the Kuiper Belt's border, embarking on a journey at the speed of light to Proxima Centauri, following the shining stars of a trinary system, unlocking the door to alien planets. Our footsteps traverse the treacherous cosmos, dreams of diverse hues scattered across the infinite universe, dancing to the rhythm of the stars and singing, exploring the mysteries of alien planets with a spirit of challenge. The courage of humanity soaring at the speed of light, an endless longing for the mysteries of the universe. In this era of adventures sailing towards those dreams, anticipating the day when we reach out and touch them with our own hands. Today, in Astrophysics Lecture 15, we will delve into the challenges and dreams of humanity regarding Pluto, the Kuiper Belt, the speed of light, and more. Your subscriptions and likes greatly support video production. Here's a brief explanation of Pluto and the Kuiper Belt in English.
Pluto was known as the 9th planet in the solar system, but it was reclassified as a dwarf planet in 2006.
Pluto is primarily composed of ice and rock, with a diameter of about 2,176 kilometers. Pluto is on average 3.95 billion kilometers away from the Sun, and it takes about 248 years to orbit the Sun once. Pluto has a very fast rotation speed, with a day lasting only about 6 hours. Pluto has 5 moons, the largest of which is Charon. The Kuiper Belt is a disc-shaped region of the solar system located beyond the orbit of Neptune. It extends from about 30 to 55 AU. 1 AU is the average distance between the Sun and the Earth, about 150 million kilometers from the Sun. The Kuiper Belt contains millions of icy objects thought to be remnants left over after the formation of the solar system. Some of these are classified as dwarf planets or comets. The most famous object in the Kuiper Belt is Pluto, and there are also Eris, Makemake, Haumea, and others. The Kuiper Belt and the Oort cloud are collections of icy objects in the outer regions of the solar system. However, the two regions differ in distance, shape, and composition. The Kuiper Belt is a disc-shaped region located beyond the orbit of Neptune, extending from about 30 to 55 AU. 1 AU is the average distance between the Sun and the Earth, about 150 million kilometers from the Sun. The Kuiper Belt contains millions of icy objects thought to be remnants left over after the formation of the solar system. Some of these are classified as dwarf planets or comets. The most famous object in the Kuiper Belt is Pluto, and there are also Eris, Makemake, Haumea, and others. The Oort cloud is located within the gravitational field of the solar system and can sometimes be drawn into the inner solar system by the gravity of external objects. The Oort cloud is a much more distant space region thought to extend from about 5,000 to 100,000 AU from the Sun. Unlike the Kuiper Belt, which is thought to be a relatively flat and uniform spatial region, the Oort cloud is thought to be a spherical cloud of icy objects surrounding the solar system. The Oort cloud is estimated to contain about 1 trillion objects, most of which are believed to be the source of long-period comets. The Kuiper Belt and the Oort cloud play an important role in understanding the history and structure of the solar system. They can also help explore the possibility of extraterrestrial life. The closest galaxy to the solar system is not Alpha Centauri, but the Canis Major Dwarf Galaxy. This galaxy is a satellite galaxy of our Milky Way, and it's only about 25,000 light-years away from the solar system. Alpha Centauri is not a galaxy, but a triple star system, and it contains the closest stars to the solar system. These stars are distinguished as Alpha Centauri, A, B, and C, with C also known as Proxima Centauri. There are 2 planets discovered in the Alpha Centauri system. One is the rocky planet Proxima b, which orbits Proxima Centauri, and the other is the gas planet Alpha Centauri bb, which orbits Alpha Centauri b. Proxima b is the closest exoplanet to the solar system and has a size and mass similar to Earth. This planet is at an appropriate distance from its star, so it is located in the habitable zone where liquid water could exist on its surface. Alpha Centauri bb, discovered in 2012, is the first planet discovered in the Alpha Centauri system. This planet has a mass 1.13 times that of Jupiter and is very close to its star, resulting in a surface temperature of about 1200 degrees Celsius. Theoretically, the only particles that can achieve speeds close to the speed of light in space are those without mass. For example, photons, which are energy quanta of electromagnetic waves, move at exactly the speed of light in a vacuum. Also, neutrinos, which have a very small mass, are believed to be able to reach almost the speed of light. However, according to the theory of special relativity, matter with mass cannot reach the speed of light because it would require an infinite amount of energy to do so. But matter with mass can reach speeds up to a few percent of the speed of light. For example, high-speed spacecraft can reach speeds of about 0.1% of the speed of light. Also, particles accelerated in high-energy particle accelerators can reach speeds of more than 99.9999% of the speed of light. Therefore, the only matter that can achieve speeds close to the speed of light in space is either massless or has a very small mass, and matter with mass cannot reach the speed of light due to energy limitations. Accelerating to more than half the speed of light is currently impossible with our technology. According to the theory of special relativity, a body with mass cannot reach the speed of light, and the closer it gets, the more energy is required. Therefore, to accelerate to more than half the speed of light would require a tremendous amount of energy, and no method of supplying that energy has yet been discovered. However, theoretically, there could be ways to accelerate to more than half the speed of light. For example, some researchers argue that using a shortcut in space, called a wormhole, could allow for faster-than-light travel. Also, some researchers argue that using a hypothetical spaceship engine called the Alcubierre drive could allow for faster-than-light acceleration. However, these theories have not yet been experimentally proven and may contradict the basic laws of physics. In conclusion, accelerating to more than half the speed of light is currently impossible, and even if it were possible, it would be very difficult. The Alcubierre drive is a hypothetical spaceship engine proposed in 1994 by American physicist Michael Alcubierre. This engine works by installing a device that distorts space in front of and behind the spaceship, so the spaceship itself does not move, but the surrounding space is pulled forward and pushed back to allow for faster-than-light travel. This method is claimed to circumvent the prohibition of faster-than-light speeds in the theory of special relativity. However, the Alcubierre drive is still just a theoretical model with no feasibility. This is because the engine requires a material with a negative energy density to operate, and such a material has not yet been discovered. Also, the Alcubierre drive may contradict the basic laws of physics in that it does not emit gravitational waves predicted by the theory of general relativity. Therefore, the Alcubierre drive is currently an unscientific hypothesis and has many problems for actual implementation. There are several theories about moving faster than the speed of light. For example, some researchers claim that using a shortcut in the universe called a wormhole can allow for travel faster than the speed of light. Also, some researchers claim that phenomena such as teleportation or quantum entanglement can transmit information faster than the speed of light. However, these theories have not yet been experimentally proven and may contradict the basic laws of physics. Therefore, moving faster than the speed of light is currently impossible. And even if it were possible, it would be very difficult. Nuclear fusion plasma, antimatter, and various other engines are all potential future spaceship engines that can reach speeds close to the speed of light. However, it is currently very difficult to actually implement or test these engines. The nuclear fusion plasma engine uses a nuclear fusion reaction to eject plasma at high speed to gain thrust. This engine is expected to reach about 10% of the speed of light. The antimatter engine uses the tremendous energy released when matter and antimatter collide to gain thrust. This engine is expected to reach speeds greater than 50% of the speed of light. Various other engines are various theoretical models, and there are researchers who claim that they can move faster than the speed of light using wormholes, Alcubierre drives, teleportation, etc. However, these engines have not yet been experimentally proven and may contradict the basic laws of physics. Therefore, nuclear fusion plasma, antimatter, and various other engines are all potential future spaceship engines that can reach speeds close to the speed of light. But the possibility of realization is currently low. Important navigation technologies that made the age of discovery possible were the triangular sail and the compass. The triangular sail allowed for sailing against the wind, and the compass provided accurate direction. These technologies enabled Europeans to discover and trade with new lands such as Africa, America, and Asia. A solar sail spaceship gains propulsion by utilizing the radiant energy of the sun. The principle of a solar sail spaceship is to spread the sail and move forward by reflecting sunlight and reacting. Since a solar sail spaceship does not require fuel and can reach speeds close to the speed of light, it is expected to be useful for future space exploration. There are various ways to equip an engine on a solar sail spaceship. For example, solar panels can be installed on the sail to generate electricity, and that electricity can be used to operate ion engines or electromagnetic engines. Alternatively, additional propulsion can be obtained by shooting lasers or particle beams at the sail. However, these methods are still in the experimental stage, and there are many challenges and problems to actually implement them. Therefore, while it is possible to apply the navigation technology of the age of discovery to the implementation of a solar sail spaceship, it has not yet been fully realized. Installing solar reflectors on multiple planets could potentially increase the speed of a solar sail spacecraft. However, there are numerous challenges and issues associated with this idea. For example, the following problems need to be addressed. Installing solar panels outside the Earth on multiple planets is very costly and technically difficult. Especially, it is even more difficult to install on planets outside the solar system. Precise control and aiming are required to shine sunlight on a solar sail spaceship. Because the orbit and direction of the solar sail spaceship can change, it is not easy to keep shining sunlight. Shining sunlight on a solar sail spaceship will heat it. If heat accumulates excessively, the structure of the solar sail spaceship can be deformed or destroyed. Therefore, an effective way to dissipate heat is needed. Shining sunlight on a solar sail spaceship will exert force on it. If the force accumulates excessively, the orbit of the solar sail spaceship can become unstable or escape. Therefore, an effective way to control the force is needed. Therefore, while it is theoretically possible to install solar panels outside the Earth on multiple planets and shine them on the solar sail spaceship, it is very difficult in reality. In the wake of Magellan's legacy, a cosmic odyssey unfolds across the vastness, past Pluto, and through the Kuiper belt it holds, venturing into realms at the speed of light beyond the trinary stars, towards Proxima Centauri's height, a dance with celestial bodies in a distant cosmic ballet, our quest for knowledge, a journey that knows no delay. Through the cosmic winds and the boundless sea of stars, we explore alien realms, removing the veils that afar, braving the challenges, fueled by an unyielding dream, humanity's spirit, a radiant and constant gleam, probing the secrets of planets yet unknown, a symphony of exploration, a melody to be sown. At the speed of light, our aspirations soar, a yearning for the universe, forever seeking more. In this age of cosmic dreams and fearless might, humanity reaches for the stars, a celestial flight. So, let us sail through the cosmic sea, towards a future where the unknown shall be free. Thank you for subscribing and watching.